learners, welcome to today's Life Sciences lesson. My name is Sina Sekeke. Now, this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Right, so today we are going to do a very important topic in life sciences, that if you master all these, you put yourself in a very good position to pass your exams. So these are the exam skills or the life skills in life sciences and the exam techniques. So what are the things that you need to look out for when you are answering? Those will be your exam techniques and how do you answer. Most learners make mistakes when they give us the answers because there is a particular way in life sciences in which you need to portray your answers scientifically so. So let's just proceed to learn the skills that every life sciences learner needs to acquire. Right. So the first thing that you know in life sciences, because we are scientists, we do a lot of scientific investigations. So there's a way of going about this, and there are different things that you need to make sure that you know in terms of conducting a scientific investigation. Those will be your variables, how to design an investigation, and then how to draw a conclusion. There are a number of things that you need to know. So let's just get right into it. First, when you do a practical investigation, you must know that in a question paper, there is going to be a question on practical investigation. Now, the first thing that you need to know are your variables. So what are the variables? Now, in planning an investigation, you need to test various possibilities or factors at one time so that we can be sure which factor gives us the result. In this case, you cannot be testing multiple factors like the effect of the sun, the effect on the plant growth, or the effect of the soil or the nutrients in the soil on the plant growth. So you need to choose only one factor that you are going to investigate, then you go on with your investigation. Then each factor now is known as a variable. Then we are going to discuss the different types of the variables. Now, and remember that each test should have only one variable so that you are able to know or to tell us what you are tracing in your investigation. Now, generally, a scientific investigation has an experiment and a control. A control is that part of the experiment that gives you the positive result, the one which you can weigh your experiment against. So tracing that particular variable that you are looking for. But in your control, you will also include that variable then to see how it would react or what the positive results will be. Then you can check against your experiment with your control. Right. So now we've said we need to have one variable, but there are actually three types of variables that you need to know. The first one is an independent variable. By now, you know every question paper that has an investigative type of question paper will be asking you to identify the independent variable from the question. Now, what is this independent variable? You need to be able to identify it in every experiment, not only on the ones that you know, but every experiment you must be able to identify it. So what is it? Now, an independent variable, it is the variable that can be controlled or changed by the investigator. So the one that you are able to manipulate, to say, I'm going to choose this time or this much time to do this, or I'm going to do this under these conditions. So the one that you are able to change as an investigator, that is going to be your independent variable. And normally, when you plot your graphs, your independent variable will be that variable that is found on your x-axis. So when you have a Cartesian plane like that, your independent variable will be here. So your independent variable will be on your x-axis or on that horizontal axis. Now I think everyone is clear now on which a variable is the independent. Then we come to the next one. the dependent variable. They go hand in hand. They always ask you one of the two or one of the other or both of them at a time. So please please make sure that you are able to identify them in a question. So a dependent variable is that one that has the effect of the independent, meaning the one that is going to be depending on the independent variable, meaning the independent variable has an effect on the dependent. And normally this is in response to what your independent variable is doing. How long you've taken it, then how long will determine the growth or the time, meaning the time if it is on the independent, then it will also influence the growth or it will influence whatever. So it will have an effect on your dependent variable. So the dependent variable is the one that is depending on the independent variable. And normally your dependent variable will come on your y-axis. So on your y-axis, you will have that variable that is dependent. Then this one, mostly it is given in the investigation. You just have to read in the steps that they were following. You need to be able to find it. And most learners confuse this one. So it is a fixed or a constant variable. Now, what type of a variable is this one? This is a variable where all the factors that must be controlled or fixed, that must be kept the same. The key word here is same. Everything that you need to keep constant throughout your experiment will fall under a fixed or a controlled variable. To ensure your validity, you will have to ensure that your fixed variables are the same. We will talk about validity later because it's something that you also need to know. Right, so those are the three variables that you need to know when you are taking or when you are answering an investigative type of question. Your independent variable, your dependent variable, and your fixed variables. Right, so validity. There is another name that we know that goes with validity. There is no question paper that will not ask you about validity or reliability. We need to stop confusing the two. Now let's take a look at validity. What do they mean when they say, how would you ensure validity in an experiment? So validity is the one that questions the how of the experiment, meaning how the experiment was carried out. When you think of an answer that is answering a validity question, think of the steps. They are normally given in your particular investigation. Think of the steps that were followed and think of how they did those and then how did they make sure that their investigation is valid. Then, here with validity, you must check that you must have all factors or all the variables that have been controlled. Like I said from the previous slide, that the controlled or the fixed variables are the ones that are going to ensure validity in your experiment. So you look for those things that you say you will have the same amount of water, the same type of plant, same amount of time, same everything that has the same. The key word here is same, meaning when you were planning and conducting the experiment, you kept those variables constant, and then you were doing the how. So that was the how part. You were actually answering the how part. When you are answering that, you are actually answering validity. Then it also speaks to the design for the investigation. So is the design appropriate? So for what you are testing, that will ensure that this is valid. Then when being asked about validity of an investigation, the answer should center around variables being kept the same. So if you find yourself in an exam and you've forgotten how to answer a question on validity, think of the word same. Everything that you follow that is the same in the investigation steps, that is where you answer that is where you are going to get your answers for validity question. Right, then we come to reliability. And I hope after this lesson, no one will be confusing the two. Now, what does reliability speaks to? Now, the idea behind reliability is that the other researchers must be able to perform exactly the same experiment under the same condition and generate the same results. Don't confuse the same that you are getting here. Now this one is saying, can I trust you with what you did? Will I be able to get the same result that you got if I follow the steps that you followed? Then I know, if the answer is yes to that, then I know that your experiment is reliable. Now, in questions which ask learners to state how the reliability of the investigation could have been improved, the correct answers could generally be the following. So here you need to take a look. What makes me to trust you or to trust the results that you are giving me? One, you have repeated the investigation. So you did not just give me the result based on the results that you got when you conducted the experiment just once. So the answer will be, you must repeat the investigation. Then it makes it reliable. Number two, you must increase the sample size. Your research cannot be reliable if you only use a smaller sample size. That can be biased. So if you use a larger sample size, then it shows that what you were investigating is actually true. So please, the answers here is you increase the sample size. Then the third one, take many readings and do the average. So as you repeat, you don't just repeat for fun. You repeat and you record. And those recordings, you're going to record once, you're going to record second time, and then you're going to record the third time. And then you compare those recordings, or you can add all three and find the average. Then we can say your results are reliable. Another thing that you can do is to increase the period of investigation. You cannot be doing an investigation that maybe investigate the growth of a particular plant, and then you do it over 5 days. How much growth can you get in 5 days? So you need to allow it time so that you are able to see that this has had enough time to grow. So how do you answer? You must increase the period of investigation. Then we can say your investigation is reliable. So please remember those. You repeat the investigation, you increase the sample size, take many readings and use the average of the results, and then also increase the period of investigation. The fifth one, select your sample randomly. If you choose your sample and then you only choose a particular organisms or particular whatever that you are investigating only in one area, or what, that can only reduce the reliability of the investigation. So for you to have optimal results, you need to ensure that your sample is selected randomly so that other characteristics are not favored or are not only selected, because they will influence the results. So the characteristics or whatever that you are investigating must be random. Right, so now what are the steps that you need to follow when you plan and design an investigation? Sometimes you get a question like this. We know that normally they would give you an investigation with a whole page that is explaining to you what the learners did, where they will give you a background of what the learners are investigating and what are the steps they followed. But sometimes they may even ask you to say, this is the story, now tell us, how would you plan an investigation for this particular scenario? So you need to put yourself in a position where you know where to start when you are planning an investigation. So let's take a look at that. Right, the first thing that you must do, you must identify the variable to be tested. Meaning you must check which one is the dependent variable. What do you want to see? What do you want to test the influence on? Then, after identifying that variable, you must also identify the variables that are going to be kept constant. How are you going to keep, or when you are planning this, I'm going to keep all my plants in one place. I'm going to make sure that they get the same amount of water. I'm going to make sure they get the same amount of nutrients, same amount of exposure to sunlight during the day, same time. So all of those that you are going to keep constant, you need to think about those also and identify them. Then identify the independent variable. Now, identify the variable in which you are going to manipulate to ensure that you see the effect on your dependent variable. Also, you must ensure that you have a list of apparatus. What are you going to use when you conduct your experiment? Because you cannot do an experiment without having apparatus that will make sure that your organisms, if they are plants, are all set in the same, or how you're going to cut them, what chemical reagents, anything. You can list all the apparatus that you want to use. So you need to think of all these before you start planning an investigation. And then the experiment. This is now you, the actual part doing, and then the control. Remember, the experiment is now the investigation part. Now, the control will be now the one that gives you positive results based on, it has the factor that you are investigating. Then, now, how will you collect the data? You need to think about this. How will you collect the data? And then select an instrument or the method that is most appropriate for collection of data in an investigation. So you cannot say you're going to collect data in a table, but then you don't know where the data comes from. How are you going to say, now, this is how I'm going to measure my results? So think of how you're going to collect that data before you even think of how you're going to present it, and then decide how you're going to record the results. There are many ways to record. You can draw a diagram, you can have a table, which is the most common one, is to have a table. Then you can have mind map, you can have all sorts of ways in which you can present the results. So you need to decide on the planning stage how you want to represent or to record the results. And then if you work with humans, very important, or with animals, you need to make sure that you get permission. This is very important, because you cannot just be working with human beings without them giving you permission to work with, especially when it comes to now the POPIA Act. People have to give you permission to even take photos of them. Now, please make sure that you follow those ethical clearance issues before you start working with humans and with animals. Right. Now, you come to the part of results. Let's say you've done your experiment. You have everything you need in front of you. Now you want to present it to say, these are my findings. Excuse me. Right. How are you going to record the results? So you can record the results in many ways. Like I've said, you can have tables, which is this one. And this is the most common way of presenting your data. You can have drawings. Sometimes if you are doing a microscopic work, then you were investigating something, then you can have a drawing of that also. You can also have descriptions, you can have pictures. Then this is how the data is going to be presented. And then you must also be able to identify the patterns in the results. So you don't just present those results. We need to be able to read what was collected. It must make sense to the person who's going to read. So be able to identify those patterns, and also identify and record irregular observations. It is not always where you are going to get the exact result as expected. So whatever that may have made your investigation to go wrong, that also needs to be recorded, so that when another scientist comes, they may work on eliminating that factor. Right, then that data needs to be reorganized. Then how are you going to reorganize the data? If you had a table, you can plot graphs. There are different types of graphs. Depending on the type of data you have, you can draw a line graph, you can draw a bar graph, a histogram, and pie chart. And I hope that you do have the skills to draw all of these diagrams, because they are a necessity for your subject. Then you must also be able to construct a flow chart. But this one, all mind maps and concept maps, you only do this one when asked to do so. Remember, especially in the exams, you don't give an answer in the form of a diagram, flow chart, mind maps if you are not asked to do so. You are going to forfeit marks for doing so. So when you take a look on your right here, you have a table that has presented the recorded data that was collected during the experiment. And then down here, you have a graph representing the data that was collected as well. So please make sure that you have the skills. But recording of the results is very important, recognizing those patterns and also reorganizing the data in a most simplified way in terms of the graphs now. Graphs can be more readable and they have all the information that you need to the person who's reading. Then, the last thing that you need to know when planning a scientific investigation, you must be able to draw a conclusion. How do you draw a conclusion? Some learners make fun of this to say, how can you draw a conclusion? Not literally so. So how do you come to a conclusion after what you have investigated? Right, so a conclusion must explain the relationship between the variables, meaning how and when the dependent variable changes over time, or if the concentration changes. So if your independent variable is changing, you are manipulating it, what is the effect on the dependent variable? So in your conclusion, we must see both variables. So you must tell us when the pH increases, meaning the soil is becoming more alkaline, then the growth of tomatoes increase. That is just an example. But you see, you are telling us and interpreting the results that you got and drawing a conclusion based on your results. So that can work with whatever variable that you were testing. It can be pH, it can be light, carbon dioxide, etc. during an experiment. Then identify and explaining trends and patterns from graphs. So in your conclusion also, a reader must be able to identify those patterns to say, this is what was happening, or these were the findings. Then they can lead me to a conclusion to say, this has an effect on this, or the variable, this variable, the independent, has this type of effect on the independent or on the dependent variable. So please make sure that you conclude your investigation in this format. Also, you can also do calculations when you are concluding to explain that data, and then you can suggest specific changes that could improve the apparatus or the techniques. Remember, we said you need to record even the things that went wrong. So when you record those, they will also inform you when you try to attempt to do the same experiment again on the factors that you need to look out for or to change or to control. So please make sure that you have all of that. And then comparing the data. So you need to check where the similarities and the differences are. You can also say that your conclusion, whatever hypothesis that you had at the beginning, whether it was accepted or it was rejected based on the data that you've collected or based on the conclusion that you can draw. Right, so we can now try to tackle an activity on scientific investigation just to check how we're going to apply now this in the exam. So we have an extract. Okay, let me just show the data as well. We have an extract. I'm going to read the extract to you, then we'll look at the results and then we'll try to answer the questions. Now, 2 students decided to investigate the effect of different concentrations of sulfur dioxide on the germination of oats seed. So already you are trying to check what is going to be in this, what are the variables here? And then they set up trays of germinating seeds under a clear plastic cover along with 5 different concentrations of sodium disulfate solution. Now, the sodium disulfate solution, please check, they are not using the sulfur dioxide. They are using the sodium disulfate. Why? They say the sodium disulfate, it breaks down to release sulfur dioxide. So sulfur dioxide is not released directly, but the sodium disulfate is the one that is going to break down and release the sulfur dioxide into the atmosphere. Right, so now we get our variables, but we have not identified which one is which. And now we get the steps or the format, the how. How did they do the investigation? They just set up the trays of germinating seed and then they put them under a cover or under a plastic cover. So let's check what were their findings. So For the sodium disulfate, at 0%, meaning when there was no sodium disulfate, for the first reading, they got 19 seeds that germinated, and then 19 for the second reading, 17, 20, and 18, meaning the seeds germinated, 93% of seeds germinated. So I hope you are able to read this diagram. So we can do another one just to check the understanding. And then when they had a 0.50% of sodium disulfate, which is going to break down into sulfur dioxide, they started to have no reading in the first instance, and then they had 1, and then 0, 0, 1, meaning the percentage of germination when the sodium disulfate concentration was 0.50 is 2%. So you can already see the pattern. Try to identify what is the pattern here. What happens when there is more sodium disulfate, and then what happens also to the germination of seeds when there is less sodium disulfate. So you have your answers here and also here. So this is a data that can be well read. So let's check what are they asking us. So okay, that was after 1 week. Sorry, we had the heading that comes after, and it's very important to have a heading for your table. So now state the independent variable in this investigation, and then name the 2 factors which might affect the seed germination and which must be kept constant. So you're thinking now, how are seeds behaving? How do I need to treat my seeds? Okay, for your independent variable, which factor am I going to change? Right, and then why was the investigation repeated 5 times at each concentration? Then you remember, to repeat is to increase what? Let's take a look at the answers. So the first one is asking you to identify an independent variable. Then the independent variable will be the concentration of sodium disulfate. Why sodium disulfate and not sodium dioxide? It is because sodium disulfate is the one that is going to break down and form or turn into sodium dioxide. So this is the one they were working with. This is the one they put, or this is the one they manipulated and changed the concentrations, because they cannot change the concentration of something that is still going to form. I think the answer makes sense. And then what are the 2 variables that you need to keep constant? Remember, you are dealing with seeds. So you want to check the temperature must be the same for all those 5 days. Then the water that you are going to use to water those seeds must be the same. So you must keep the same amount of water, same temperature. So those are the variables that you're going to keep constant. And then why did they repeat this 5 times? To get the estimate, remember we said you must get the estimate when you're doing more, and also to increase reliability. This is now how. So they can ask this question, this one, vice versa. They can ask you, how can you improve the reliability of this investigation? Then you will say you are going to repeat the investigation and get the average. Or they can ask it in this way in which they asked here, to say, why did they repeat, and why why did they repeat this a number of times? Then you know, when you talk about repeat, you are now talking about reliability. So that must have been a very nice exercise to get you now. So remember, we said your data, you must be able to present the data in a form of graphs, in the form of flow diagrams, in the form of flow charts, and in the form of diagrams. So now you need to possess the skills to draw line graphs. Most learners make funny mistakes when it comes to line graph, so we need to stop that and eradicate so that you can get your full 6 marks when you are asked to draw a line graph. So how do you get that 6 marks? Let's get into it. Right, there are certain steps that you need to follow. Step number 1. You need to identify the dependent and the independent variables here. So do you see the variables play a very important part in every investigation? So if you are not able to identify those, you will not be able to draw your graph. You will not be able to know which one comes on which side when you draw your Cartesian plane. Right, so from the information that you are given, usually this information will be in a table format, then you will be presenting it in a form of a table. Right, so that is the first step. Identify your variables. So your independent variable, like we said, this is the variable that is going to change, or the one that you are going to manipulate. Your dependent variable is the one that is going to be measured, or the one that the independent has an effect on. Right. Then this is an example of the data that you can get in the form of a table to draw a line graph. So we will be working with this data here. So you have time in this investigation. They had time in hours where they put all their plans or whatever for this amount of time from 0, 5, 9, 13, 17, 20, and 24. And then the temperature increased to 16, 24, 28, 26, 21, 19, 17 as time went up. So from the table, you are able to tell that information, but we still need this information to be in a graph form, a line graph. So how are you going to do that? Usually in a table, this is not always the case, but in most cases, your independent variable will be the first column. So this first column here will be your independent variable. And in your graph, remember we spoke last week, where do you put your independent variable? You put your independent variable on the x-axis or on the horizontal axis. So already for being able to identify that, it pushes you towards getting those marks. Then it makes it easy to know that your dependent variable will be the one that is on the column that is on the right. Step number 2, you are done with identifying the variables. Now you're going to draw a set of axes, meaning your x-axis and your y-axis, and then you put your variables. Put your variables. Then here you do have, so this is time in hours, that was, remember, our independent, and then temperature here was our dependent. Right, so you are done with step number 2. Then step number 3, this is the one that most learners get wrong also. You need to choose a scale for the x and the y-axis. Okay, can we please go back to the table? I just want to show you something. You look at the table here, our data in time is 0, 5, 9, 13, 17, 20, 24. This time is not in equal intervals. So you need to make sure that when you choose your scale, the intervals are equal. Let's see how you do that. Right. You must make sure that the scale includes the highest numbers on the tables and the lowest numbers. Then you work with the multiples between those numbers. Then the space between the numbers that you are writing must be equal. So for an example, if you are going to plot that data to say 0, 5, 9, 13, 17, 20, this is wrong because the space between 0 and 5 is not equal to the space between 5 and 9 or 9 and 13. So this is not equal. So you must find intervals that are equal. Work in multiples. You can use multiples of 5. They will include all the numbers. So please make sure that you choose a suitable scale for the data that you are given. And then step number 4, you must place the dot at the point of the two values for each result where they are going to meet. So now this is the plotting part. So for the first one, at 5, you had the temperature of 24. Then you're going to put your dot here. So you go to the time in hours. The first one is 5 hours. So your 5 will be between your 4 and 6 here. Then when the time was 5 hours, how much was the temperature? Temperature was 24. Then you're going to correlate that with 24, and then you put a dot where the 2 points meet. So that is now you plotting your points. And then, yes, here. So this arrow here just shows you what we just did. Then step number 5, join the dots using a ruler. I know in most cases you want to use your own free hand. A ruler looks neat, so please make sure that you use your ruler to plot and join your dots, because look at me now trying to plot with my hand. It goes crooked a bit, so please make sure that you use your ruler to plot or to join the lines. Step number 6, the most important step. You must give this graph a heading. It is not a graph of anything. It does not tell us anything if you don't tell us what this graph is talking to. And when you are telling us about the heading, your heading must include both variables. What are those variables? Your time in hours and temperature. Those must be in the title or in the caption of your graph. And then let's check. So here we have a caption. It says a line graph showing the air temperature measured over a period of 24 hours. Where are your variables? So here is your first one, which is your 24 hours, and your second one here, temperature. So both variables are represented in your caption. Please make sure that your caption has both the variables. Right. Now, this is just another example that shows you when you have two organisms. Let's say you have 2 lines. So in case of 2 or 3 lines in a graph, you need to ensure that you include the key. So if you don't write it here, the solid line 1 will represent the carrot, and then the dotted line 1 represents the beetroot. So you can write it here, or you can have the key on the side that gives us an indication of which line represents which. So this can also be a case to say, on the same set of axes, plot 2 line graphs of this and this, or in this and that. So you need to ensure that it has a key. Then, now let us draw a line graph from an activity. So let's just read what was happening here before we attempt to check our data or our results. A person took part in an experiment on the eye's response to light. A lamp was placed at the 7 different positions from the person's face. Now, the diameter of the person's pupil was measured at each position. Now, the table below shows the diameter of the person's pupil when the light was placed at various distances from the person's face. It's also important to have a heading for the table. So you see, this is the distance here in the first column, and now you know, on your first column, you already know, this is your independent variable, and you can see, you are the one who is manipulating. You are moving the lamp 1, 2, 3, so you are moving it at 7 different positions. And then you measured what was the change in the pupil size, or in the diameter of the pupil of this person. When you put it at 1 meter, the pupil was 1.2. When you put it at 4, the pupil was 3. So that is how you read this table. Now, draw a line graph to represent the information given in the table above. What are you going to do now? Already when you draw a line graph, you know. So a line graph indicating the diameter of the pupil of the person if the lamp is placed at different distances from the person. So this can be your caption. So it already has the 2 variables, so the diameter of the pupil and the distances. So you can get 1 mark for writing the caption with both variables. Then you draw your Cartesian plane, then you know this represents your x-axis and this will be your y-axis. Now on your x-axis from the table, you've already identified that the distance will come at the bottom, and then what will come on the left here going up vertically is the diameter of the pupil. Then from here, once you are done with this step, I am telling you it's going to be easy now going forward. You are only just going to put the numbers, remember your scale at the intervals. So here it's 0.8, 1.6, 2.4, 3.2. You may not have these numbers as they appear here. So you are only going to do what? You are going to choose a scale that is suitable for the data you have from your lowest number to your highest number. Then you plot your graph. How are you going to plot your graph? For the first one, when it was around here at 1, what was the reading or what was the diameter? It was around 0 point here. Right, and then you plot your first point. Then you come with your second point, with your third. Remember from the data you have in the table, and then you join your points using a ruler. Just look at how beautiful that ruler came out there. So that is how you get your marks for drawing the graphs. Right, so I just want us to take a look at the bar graphs quickly because they are not that much different from the line graphs, and then we're going to take a short break of 5 minutes while you digest and try to look at other questions that deals with line graphs and bar graphs and also the scientific investigation. Right, so let us take a look at this bar graph quickly. It is not too much different from the line graph. It's the shape, now is how you draw it. So let's check. Also, when you are drawing a bar graph, you are still going to check your variables. There, you are going to write a caption. We've done that also. Then the caption should include both variables. Same story. Draw the y-axis and the x-axis, your Cartesian plane. Then you write the dependent variable on the y-axis, and then you draw your x-axis on your independent variable on the x-axis. Then you must ensure that the scale lines on your y-axis are perfectly spaced. Then the scale on y-axis should also be at even intervals. You can use a ruler also to measure the scale on the x-axis. Now the bars should be of equal. Now this one is very important. This is what makes the bar graph to be a bar graph. The bars should be of equal width. When you draw a slim one, and then a thick one, and then a slimmer yellow one, all the widths, when we're talking about the width, we are talking about this. So please make sure that all the widths of your bar, measure it. Don't take a chance, because then you're going to lose marks. It must be of the width, equal width, and the spaces between your bars also must be equal. This space also, we are going to measure it as you move with your bars. So the spaces between the bars must be equal, and the width of the bars must be equal. Please make sure that you do that. And sometimes your bar will start slim at the bottom and then it goes thick at the top. Then the next one will go thin at the top and then thick at the bottom. We don't want that type of graph. Use your ruler. Then how to draw a bar graph? We have this information, the points, these are the points, and then the number of organisms. So also the type of graph will depend on the type of data you have. Right, so let us take a look at the example here. Now the bars must be of the equal width, we've discussed that, and it must be the same distance apart, meaning the spaces between the bars also here must be equal, and also the same width. So if you take a look at this bar graph here, it is perfectly spaced in between, and also the width of the bars are equal. So at 1 you found 10 organisms, at 2 you found 12, at 3 you found 8. So it is easy to read. Please make sure that you have all of this. So all of this is the same, then only this part in the middle here is different and very important. This is where you are going to lose your 2 marks if your bars are not of equal shape and size. Then this is just an activity that we can look at for drawing a bar graph. So I want us to go back a bit. Then you must study the table below, which shows information on some of the earthquake-generated tsunamis which occurred between 1918 and 2003. So when we go for break, I want you to analyze this table here. Just check. This is the table that shows the earthquake-generated tsunamis. So these are the tsunamis that were generated by the earthquake from 1918 up to 2003. So these are the areas or the countries in which they were found or in which they occurred. And then these are the values on the Richter scale. And then these are the number of deaths that were caused by this tsunami. Then an examiner can ask you any any type of question from this type of graph. They may not even ask you to draw a line graph showing all this information here. They can choose for you to draw from which year to which year, and then they can also choose to say, show us the number of deaths in the different years, or show us the measurements, how they measured on the Richter scale in the different areas throughout the years. So, but in this case, they are asking you to draw a bar graph to show the number of people killed. So here, this is what we'll be working with. People killed by tsunamis between 1953 and 2003. So we are not going to plot from 1980. You must be able to read and identify. So from 1953 to 2003. So your data must include only this. So this will be the areas: Turkey, Pakistan, Philippines, Mexico, Japan, and Algeria. And then you have your number of deaths. So this is only what you are going to plot, and also this. Right, so let's check. So for the answers, you have Turkey, there were 1,070 people who passed on. Pakistan, 5,300, Mexico, 9,500, Japan. So you are able to read all of this from your table, and you've only included the areas that you were asked about. So you will have your x-axis there, your country, and then number of deaths. It must have been cut by the question paper here, and then you have your heading there. It says the bar graph to show the number of people killed by tsunamis between. Now this is very important also. You need to include this, a variable when, because it cannot be from 1973 or it cannot be from earlier on. So they only started from 1953 and 2003, and the areas must also be specific because we had other different countries. So you must be specific in which country does this graph speak to. How are you going to get marks? Going to get your mark for your correct heading. The type of graph, very important. For it to be a bar graph, there must be spaces in between the bars, and then you have your y-axis here, and then the label of both axes are correct, and then the plotting of bars. So this is just the bars being plotted. Right. I'm not sure if we can continue to the next one. Right, I think we can stop here for a short break of 5 minutes, and then we'll continue with another type of graph, which is the histogram. back, grade 12s, like we were doing before we went for a break, just for a comfort break. We are now going to continue with the histogram. So taking off from where we left off now. How do you draw a histogram? A histogram is drawn exactly the same way as a bar graph. However, there's a difference. The only difference is that the histogram is used when the independent variable is groups of information along a continuous scale. So a continuous scale, I will show you what a continuous scale is. So, but then the independent variables will be grouped. Now, you must note that in a histogram, the bars are drawn without spaces between them. So that is what makes a histogram different from a bar graph. So let us take a look at an example. So this is a table representing a number of pupils in each percentage range. So because it's a range, this is a continuous scale. So what do we mean by that? From 0 to 19, this is continuous. So you can have the value for 0 to 19. Then for 20 to 39%, there were 5 people. 40 to 59%, there were 11. 60 to 79, there were 16. 80 to 100, there were 3. So how are you going to put this in a histogram? Right. There we go. So this is a diagram of a histogram. So the range in percentage would be the first range, the first values here will be from 0 to 19. So that is your first range. And then your second one, where there is 5, you're going to have what? It's 20 to 39. So that is your second range. So this is what it meant when it said the data is represented in a continuous, or the range on the x-axis is continuous. Then for 49 to 50, so but I think you get it, 49 to 50 here, and then you have here it's 60 to 79, and then 80 to 100. So all of this data is in a range. So you are going to draw it, but take note, there is no space between the bars. The bars are clustered together. So you need to take note of when do you draw a histogram, when your data in the independent variable is given in the form of a range. So this is the bar graph showing the number of pupils in each percentage range. So you will still have your caption, you will still have your dependent variable on the y-axis and your independent variable on your x-axis. You still have the bars, however, the bars now are clustered together. There's no space in between. However, the width of the bars must still be the same. Please don't draw a thick one, a thin one, and a thick one again. So you still have those things that we look out for when we mark a graph. However, the only difference is going to be the bars being close to one another because our data was given in a range. Then pie charts. In the exam, when you go to write your exam, we always tell you, bring a protractor or a compass. So this is what you're going to use to draw a pie chart. This is another skill that you need to possess as a life sciences learner. Right. How do you draw a pie chart, or what is a pie chart? A pie chart is a chart that shows the data as a percentage or as a relative proportion of the total of the circle. So, meaning the data that you have, it's either you are going to the data in percentage, you are going to be given the data in percentages, then you need to give us that as relative in proportion to a circle, meaning you have to divide it into all the angles of a circle. And we know that the angle of a full circle is 360. So you are going to divide those into, for them to fit into 360, meaning they need to be converted to angles before you do that if you were given the data in a percentage. So you draw a pie chart by dividing a circle into sectors or slices. You do not guess to say this one is 79%, therefore it's going to take up this much from the circle. You need to convert that value to a degree. So you are going to divide it into sectors or slices. So you must think of a pizza. Then you can also, okay, for you to represent each item as a percentage of the whole. Now, a complete circle represents a whole 100%. So we know this will be a whole 100%, but in degrees, it will be your 360 degrees. So you must make sure that your 100% fits into the 360, and then half of a circle will be your 50%. Then we will talk about that. So how do you draw a pie chart? Step number 1, to draw a pie chart, we need to represent each part of the data as a proportion of 360. Why do we need to do that? Because there are 360 degrees in a circle. We've already explained. So let us take a look at the data that we have in the table on the right here. So the data shows us, the table below shows the percentage of carbon dioxide emitted by different sectors in a certain city in South Africa. So they will show you now, this is the sector that is written on the left-hand side. So here you can identify your dependent variable, but you are not going to represent that in a pie chart, because as a pie chart, you just need to put the sectors. Right, so you are going to have the sectors and the carbon dioxide that is emitted. So the first sector is your transport. How much is transport emitting to the environment? How much carbon dioxide? They are emitting 25%. Residential, 27% emission of carbon dioxide. Industrial, 15% of carbon dioxide emission. Commercial, 28%. Other, they will be emitting 5%. So we have all of these now, percentages. Now we want to put them in a pie chart. What is the first thing that you need to do? You must add all of these together. So you add your 25, 27, 15, 28, and 5 here. They will all amount to 100%. So all your data must amount to 100%, or you can say 100, because this is in percentages, it's 100%. Now, once you've added them and then you have your 100, you must keep it in mind that the total of all the sectors is 100%. Now, how are you going to put the 20% of the 100% into a pie chart, or the 25%? Let's go to it then. Step number 2, you must do the following calculations of the angles of each sector. Then how do you do that? This is the formula here. Each value, or the total, you are going to divide by the total, then you are going to multiply by 360. So the value here will be your 25 divided by 100 multiply by 360. Then you get now your answer in degrees. So the first one, which is for transport, will be your 90. So you can do a quick calculation there where you are. Then you calculate for transport. You have already done so. It's 90 degrees. Now your answer is in degrees. Your residential, they were 27% out of 100%. Then you multiply by 360. You always multiply by the number in which you are converting to. So if you want to convert something to 360, you multiply by 360. If you want to convert to 50, you multiply by 50, and so on. Right, so for residential, you are going to say 27 divided by 100 multiplied by 360, then you get 97.2. Industrial, 15 divided by 100 multiplied by 360, it will give you your 54 degrees. Please take note of the value here. It is now in angles, right? So you have all those, so you have 90, 97, 54, 108, and 18. The tip that I always give here is, for you to be able to plot them into your pie chart, before you draw, or no, after you've drawn your circle, please make sure that you start with your biggest angle, and then it will give you the proportion of the rest. But you don't just guess, you use your protractor to actually measure it, right? So step number 3, you are now going to use a compass. If you are able to use a compass is this instrument over here to draw a circle. Or you can use a protractor to draw a circle. And please take note, when you use a protractor, sometimes there are spaces between here. If you take a look at this protractor here, there's a space here that is amounting to nothing. On the line that you are drawing, please make sure that you put the 0 and the 180 on that number, or on that line where you are starting, because it will not give you the 360 when you are trying to get your segments. It will give you more than 360 because you've also included this space over here that is not calculated. Please make sure that you know how to use your protractor correctly. Then you draw your circle using your protractor, then you can turn it around. You draw your first 180, then you can turn it around, then you draw your second 180, then it will give you a full circle of 360 degrees. Then what do you do with that circle? You are now going to use the values that you have calculated to put them into the segments as degrees now, as angles in degrees. So we know what is our biggest one. Our biggest was the commercial one. Commercial gave us about 108, I think. So you will take your protractor. Your segments do not have to be according to the circle the way it is, but the way in which you proportion, it will always come to this these shapes or these sizes. Then we use the one that is laminated, we put it on top of your one, and then we'll see the proportion or the segments are equal to what we have. So you start with your biggest circle and then you count. You know that from 0 to the upright angle, it's your 90, and then when you go down you get your 180. When you go a bit further down into the lower part, you get your 270 and then 360. So you're going to share using your diagram the angles of the biggest angle, and then you draw that angle. So how do you do that? Let's say you have your circle there. Please excuse mine because it is not drawn to scale. And then you know when you use your Cartesian plane like this, I normally advise that you do so. So you have your 0, your 90 degrees, 0 degrees, you have your 180 degrees, you have your 270 degrees, and then your 360. So your biggest angle will be 100. So you have 90. So about 100 will be here. Then you start your line from there, you put it back to the point where you started, and then you erase this one. I'm not going to erase it because I want you to see when you draw a Cartesian plane how you're going to proportion. Then for this segment, you can even have a key, or you can even color them, you can do anything. Then you will know that for this segment, all of this, it is now your commercial. So labeling here is very important. Or you can even have a key on the side that is explaining what this segment will be. And then you come with your other sections and then you proportion them accordingly, according to the angles that you have. So you must label them and then use a key, and then you will end up with a pie chart like this, and then in order for you to get your full marks. So sometimes you may not have labels in between. So you see, no labels here. However, a key was used. You know, the green color will be your transport, and then other will be blue, and then residential is your orange, pink is your industrial, yellow is commercial. So even if they were not written here, I can just come to the key and be able to identify them. And also the heading here and the caption, still very important. The carbon dioxide emissions in different sectors of a city. So the city was not mentioned, so you can just say in South Africa also to be more accurate and more specific. So how we make a pie chart, or how do we mark it? Yes, sorry about that. Firstly, we are going to mark the correct type of graph. So have you drawn something that is looking like a pizza there with all the segments? And then the title of the graph. So it must have carbon emission and the sectors, and then also the area you can include in a city in South Africa. Then you're going to get 1 mark also for that. Then for all your calculations, if 1 to 4 of your calculations are correct, you are going to get 1 mark. If all 5 calculations are correct, you are going to get 2 marks. And then the correct proportion for each labeled sector. You are going to get 1 to 3. You are going to get 1 mark if 1 to 3 sectors are correct. But if 4 to 5 sectors are correct, then you are going to get your full 2 marks. Then how many marks can you get out of a graph? 6. So all the graphs, they will give you 6 marks. So it will be a 2, 4, 5, 6. Please make sure that you collect all those marks. And even if you don't have the protractor, which I discourage encourage you to get into an exam without having a protractor, because now you know you need a protractor, right? You can still get the 1 mark for the type of graph, even if it's not drawn to scale. You can still get 1 mark for the title of graph. You can even get 2 marks for calculations that you did correctly. So you can get 4 out of 6 without even drawing the correct thing. What am I saying? You do not leave a pie chart even if you don't have what you need, or even if you cannot proportion the sectors. You collect those marks, right? This is an activity that will allow us to practice what we've just learned. A group of learners conducted an investigation to determine the average amount of water used by a household. They collected the data on water use from 5 families in the neighborhood. The results are shown below. The purpose for which water is used. So water is used for flushing, baths and showers, gardening, washing clothes and dishes, cooking and drinking. Then the average amount that is used per household in percentage. So for toilet and flushing, the 30% is used. Baths and showers, 25%. Gardening, 15%. Washing clothes, 20%. Cooking and drinking, 10%. So now you need to represent this information in a form of a pie chart. You need to remember the first step. What is the first step when you get data like this? The first thing that you must work on are the values that you have in percentages. So what must you do? The first part, you must total them. Before we get to the solution, yes, so you must add your 30 plus 25 plus 15 plus 20 plus 10. All of them, they will give you 100. So they all are equal to 100. That is the first step that you need to do. Then what do you do with that 100? You now convert them each for the proportion that you want for your sector. So for toilet and flushing, you had 30% divided by 100. Remember the formula, multiply by 360 because you're converting to 360. Then you get an angle of 108 degrees. This 108 is the one that you're going to put in your pie chart as a sector in a degree form angle. Baths and showers is 90 degrees. Gardening, 54 degrees. Washing clothes and dishes, 72. Cooking and drinking, 36. All of them, you follow the same formula to get these angles here. So when you work with your pie chart, now you are going to plot these angles in 360. And when you add these angles also, just to verify your information, they must all also give you 360 or somewhere about there, because some will have commas and they will not give you, maybe they will give you 359,7 something, but you know that is 360. This is just to verify that you've done the correct thing, because all of them must fit into a 360. So let us take a look at our pie chart. So for toilet and flushing, so you would have that value of 108 put here. So you can even label it if you want to, you can label them. So, but now you see baths here, they used a key. They did not write in the pie chart itself, but you can still get a mark for using a key. So this is how you are going to proportion all your angles based on the values you had. Okay, another skill that you need to have is diagrams. You may be looking at something and then we ask you a process and then ask you to draw a diagram or whatever. So there are skills or there are certain ways or principles that you need to follow when drawing a diagram in life sciences. You don't just draw a diagram. First, each diagram must have a title and a caption. Very important. This tells the reader what they are looking at. Whether it's a table, it's a graph, it's a diagram, it must have a caption. Otherwise, if it doesn't have a caption, it's a potato. Right. Then you must use pencil to draw. Sometimes you take chances. You didn't bring all your stationery, you draw in pen. You will lose marks. Make sure that your drawings are in pencil and they have clear, smooth lines. Then your labels. If your diagram is in pencil like this, then you take your blue pen you draw the label lines, or you can draw the label lines in pencil still, but the labels here, the names must be in ink. Please make sure that you write that in pen. And the diagram must be large enough to see all the structures that are in the diagram. So you are not going to draw something as small as this. The rule that I can accept is at least it must be within more than 8 lines. So if your diagram is more than 8 lines, it's a bit big enough to see all the inner structures that you are going to label. Please don't draw something very small like this. And then the diagram must also be positioned in the center of the page. Don't draw it towards the right of the page or towards the far left. Just make sure that it's just visible enough in the center, and it will also give you enough space for you to draw your label lines and also to to write the labels in ink. The diagram must be 2-dimensional. You must show the length and the width only. There are learners who have some artistry. Please don't use your art skills to draw life sciences diagrams. We know you are able to draw in 3D or any other diagram, but our diagrams are very simple. We need them in 2D then so that you can just see the labels very clearly. You also do not shade. We do not draw a diagram where you use your pencil to shade the parts. All the parts must be clear. Unless you are drawing a nucleus, then you will definitely have a darker nucleus which is shaded like this. But however, the rest of the diagram should not be shaded. Or if you have a diagram with maybe the chromosomes, they're asking you to shade them and show which ones after crossing over, only then you can shade. But with other diagrams, when you are just asked to draw a diagram, please make sure that you do not shade the diagrams. Right. And an example of a diagram that you can have in life sciences is this. This is a diagram showing gaseous exchange across an alveoli. So you see your diagram is big enough, it has a caption, it is drawn in pencil, and then the label lines are drawn, and then you have your labels there. Well, everything here is in ink, it's print, but let's check what must you do. So you must draw the lines with a ruler. Please don't use your free hand. Then the lines must not cross each other. So you cannot have your alveolus like this here, alveolus, or have another part here crossing. Make sure that all your lines come to the right parallel to each other. If parallel cannot work, you can also bring it from the far, but all of them must come to one side. We'll talk about that now. Lines must not touch the structure that is labeled. Or they must touch, they must actually touch, yes, because then sometimes you get a label line that is here, and then it's not clear whether you want this outer label or this inner label. So make sure that whatever that you are labeling, your line touches it. And then the lines on the side of the diagram, if they are few, so all of them must be to one side if they are few. But then if there are many, you can have them just a little bit to the right, but please fight for them to be on the one side because we don't want a spider diagram. Then the labels must be aligned neatly and preferably one label below the other. So that is how your diagram is supposed to look like. Tables. Sometimes you're asked a question to say, tabulate the differences between, or please draw a table from an investigation, draw a table of the results. What must you look out for when you draw a table? First, okay, this is a table showing the differences between, or the similarities between the humans and the African apes. Okay, the differences actually between the humans and the African apes. So the foramen magnum is more in a forward, and then the foramen magnum towards the back of the skull, C-shaped spine, S-shaped spine. So these are the differences. So you see, this is a table. Now let's check what are the things that you need to look out for. First, the table must have the caption of each column. So this is column 1, this is column 2. You must give us a heading of what are you going to find in column 1. So you are going to find the characteristics of the humans, and then in column 2 you are going to find the characteristics of the African apes. Those are the captions in each column. Then Draw the rows and columns with a ruler. Sometimes you write with invisible rows and columns. You just write the headings and then you want us to see an invisible table there. You take your ruler and you draw those lines. We want to see these lines dividing the rows. We also want to see this line dividing the columns. So this was just row 1, row 2, row 3. Take your ruler to draw those. Don't let us see an imaginary table there, because then it is not a table if it does not have the lines for the rows and the columns. Now the same factor is compared in each row. Here you are talking about the foramen magnum in a more forward position. You cannot start talking about the teeth, they have gaps in between. They do not correlate. So what is on the left must be the same, must be compared to what is on the right. So you must be speaking of the same factor. Right. So those are the things that you need to look out for when you are drawing your table. Then calculate the percentage difference. That is another question that you get from maybe an extract that you are given of the data. Then you need to tell us how much that particular variable increased by, from which year to which year, and then how do you do? The formula is 1. You need to make sure that you know that formula. So when you have to calculate the percentage increase or decrease in the data, you divide the difference between the values by the starting value. I know it might not make sense to you, so let us do it practically so that you know. You divide the difference between the values by the starting value. So let's see. For an example, the following table is a summary of the rhino poaching incident for South Africa from 2000 to 2010. Let's see the table. So in Northwest from 2000, there were 0 rhino poaching, and then in 2010, there were 44. The total were 63. Eastern Cape, there were 0 in 2000 when they started. Then in 2010, there were 2. So let's check. They may ask you how much did it increase by, or what was the percentage increase from 2005 to 2010. So you must be able to do that calculation. How do you go about that calculation? So let's check what they are asking now. With what percentage did the poaching of rhinos incidents increase in Northwest since 2008 to 2010? Then you must be able to show your calculations. So you're going to come to your table here and check, okay, 2008, it was 7. And then 2010, they increased to 44. They don't want you to tell them what is the difference. You need to tell us what is the percentage increase. How much did they increase by? So the formula here says you need to divide the difference between the values by the starting value. So what is the difference between the values? The difference will be 44 minus 7. Then you divide that by the starting value, which is going to be your 7. Let's check. So you are going to have this now. The starting value, or the biggest value in 2010, the number of rhinos that were poached were 44. But in 2008, there were 7. So this is now the difference that we're talking about. So you take the difference and then you divide by the starting value. So the starting value is your 7, and then you multiply the whole thing by 100, because you are looking for a percentage. You are looking for a percentage. So this 100, it indicates a percentage. Then you get the answer is 529. So how do you answer this? You say now the rhino poaching incident has increased by in Northwest has increased by 529% from the year 2008 to the year 2010. That is how you do a percentage increase. Right, remember, you want to know how many times more than your starting value. That is why you divide by the starting value. So that is how you do your practical calculations if they are asking you to do a percentage increase. So what are the exam techniques? You are now preparing yourself to be writing the final NSC exams. So these are the things that you need to look out for or to keep in mind when you are writing life sciences and how to answer life sciences. So when marking, there are certain principles that we use in life sciences, and I hope your teachers have been penalizing you for all the mistakes that you were doing, because they are now going to yield positive results, because you shall have learned not to throw away your marks by following these principles. So all life sciences papers are marked according to these principles that are found in the marking guidelines. So what are these principles? Let's check. You check them, you know them, so that you avoid making mistakes, because then you are going to lose marks. The first one, if more information than marks allocated is given, you stop marking when the maximum number of marks are reached and place a wavy line and max to the right. So sometimes you are asked to explain something, and then you only a particular portion of a process, and then you describe the entire process. We are not going to mark your entire process and give you more marks than those that were asked for. So we are only going to mark up to the maximum where we get the maximum number of marks that we needed from the question, and then we are only just going to put a wavy line like this, and then write that you've reached your maximum. And then if, for example, 3 reasons are required and 5 are given, this may sound very cruel, but it happens. And please make sure that you write and you do not waste even your own time. So we're only going to mark the first 3, irrespective of whether all or some of the remaining ones are correct. You may start with the incorrect ones and then end with the correct ones. The principle says we are only going to mark the first 3. So if you are supposed to get 3 marks, you may end up getting 1 mark. So make sure that you write things that you are sure of, and you do not keep the marker guessing. Another thing that you need to look out for, if a whole process is given, when only part of it is required, you read all and then you credit only the relevant part. So this is also similar to number 1, but here we are going to look for that one that we want, and then you are not going to get credit for all the work and the time you've wasted writing all other points if you were only asked about 2 points in that particular process. Train yourself to read questions and answer correctly or answer relevant things that were asked for. Now, 4, if comparisons are asked for and descriptions are given, we are only going to accept them if the differences or the similarities are clear. So you cannot be asked to compare the dentition of the African apes and the humans, and then you tell us they are found in the mouth, or they are found. Now you are describing it. We can only give a mark if that description is clear. But sometimes you give descriptions that are not clear, that may not even award you a mark. Please make sure that you know how to write your differences. If tabulation is required but paragraphs are given, candidates will lose marks for tabulating. Every time when you are asked to tabulate humans, African apes, you need to be able to draw a table. There is always going to be that 1 mark for the table, the compulsory mark for the table. So if you did not draw a table, and remember I just said to you, a table has a distinct line between the columns and the division lines between the rows. So you are going to lose a mark if you don't represent your data like that. Now, if diagrams are given with annotations, when descriptions are required, candidates are going to lose marks. So sometimes you may ask to describe something, and then you draw a diagram and you tell us this is what, and then you tell us what it does in brackets something. So those are connotations. Please make sure that you write a full description of what you are asked for. Do not write what was not required or answer in an inappropriate way that was not asked for. Make sure that you read your question carefully, because then you are going to lose marks. If flowcharts are given, Instead of descriptions, candidate will lose marks, same as the one above. Connotations, diagrams, or flowchart given when the description is asked for, you are going to forfeit those marks. If sequence is muddled and links do not make sense, where sequence and links are correct, we are going to credit. But where the sequence and links are incorrect, you are not going to be credited. Because if the sequence and links become correct again, then we can resume marking again. For an example, there are certain processes in life sciences that you need to explain, and you find they have a cause and effect. Something, they follow a sequential event. So something will only happen because the previous thing happened. So we need to trace that. But if yours, you just remember the points and then you write them randomly, you may lose marks where the sequence is not followed, because we may be tracing that cause and effect. Please make sure that you follow that logical flow when explaining your processes and your phenomena in life sciences. Right, number 9, non-recognized abbreviations. We are only going to accept them if defined in the answer. Then if not defined, you're not going to get credit for unrecognized abbreviations, but you're going to credit the rest of the answer if it is correct. Don't use your own abbreviations. We know sometimes when you study, you want to abbreviate the words in a way that you are going to understand them. However, that may be dangerous if you still keep on using those abbreviations in your exam or in your final paper, because they may not be recognized in life sciences. Make sure that you use only the recognized abbreviations, not your own. Because if you say ATP, then we need to know what is ATP. You must be explained in your own way, then what is that? And if it is not explained and then it does not make sense to what you're explaining, then you may lose those marks because you are the only one who knows what ATP is. Right. Then wrong numbering. Please be careful. If answers fit into the correct sequence of questions, but the wrong number is given, it is going to be acceptable. However, if this is not the case, you may lose marks. 13, if only letter is asked for and only name is given and vice versa, no credit is going to be given. If the letter is asked and then only write the letter. If the letter and the name is asked, write the letter and name. Don't write unnecessary things. So sometimes they may give the label of the part, the label and the name of the part that is doing da 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 da. So you need to tell us if it is the cornea or something, then you're going to get credit for the label that you've just written and the name itself. Please follow that instruction very carefully. If units are not given in measurement, candidate will lose marks. Memorandum is going to allocate or will allocate marks for the units separately. So if your answer is supposed to be in milligrams per second or however, you need to make sure you write that unit. Otherwise, you may get a mark for the value, but lose the mark for the units. And then 15, caption. I've emphasized this one. All illustrations, diagrams, graphs, tables, etc. must have a caption that is defining what is happening. Then some additional notes that you can take note of for the calculations. When doing calculations, you need to show all the steps that you followed to get the answer. Very important because there are marks for the steps. Also give a unit. Then if your answer has decimals, you must round them to 1 decimal. Don't write the whole value number, just write 1.64, 1.67, just keep to 1 decimal. Then, but if you have to answer how many humans or cows, you can't say 1.6 humans, because what is half a human? So then you have to say 2 humans, because you cannot have half an animal or half a human. Please be careful of the context in which you are answering for your calculations. Then, multiple choice questions, there's also a skill to answering this question. You do not leave a multiple choice question open. 1, you must read the question while covering the answers. Why are you doing so? You are testing yourself if you know the answer without letting the answers manipulate you or manipulate your decision. Then you must think of the correct answer on your own. Then you must then go look look for that answer that you have in your mind. And then you can write the letter. That is when you are sure of your content. But if you do not know the answer after point 1 and 2, then you must look at other options. Then you can eliminate those incompletely correct. So there will always be those two that you see, no, these are completely off. Use the method of elimination. You eliminate those two, and then you are going to now be left with 2 options that you can choose from. Always answer these questions. I cannot emphasize this enough. You always have a 25% chance. If you are given 4 options, each option is 25% each. So what are the chances of getting it right or wrong? 25%. So make sure that you answer multiple choice questions. I do not like it when you leave gaps in multiple choice questions. In fact, it does not even make sense. Please make sure that you choose something there. Right. For column A and column B, this question, you need to be careful of this one. This is not a multiple choice question. It is not a multiple choice question. If it was a multiple choice question, these questions would have been in multiple choice 1.1, but you find this on question 1.3. How are you supposed to answer these? Look at the statement in column A. Decide whether the statement in column B is the answer to, or it corresponds to the statement in column A. You have 4 options: A only, B only, both A and B are correct, or none. So this one is not like multiple choice where you're going to say A and what? A and B, or you say B for what? For both. So you must be specific, because this is not a multiple choice question. Now, write only A only, B only, both A and B, and follow the instruction in the question. How are you going to remember this? Remember that this is not a multiple choice question. Then if you don't know the answer, guess what? You still have 25% chance of getting the answer correct. Tabulation, always draw a table with headings in columns and rows. We've spoken about that. Then the table must also have a caption. You must compare the same characteristics, legs with legs, eyes with eyes. You cannot be talking about legs this side and then eyes this side. Right. And then, right, yes, that is that. Then what is it that you need to bring to the exam when you are writing? First, you need to bring a pencil and a pen. Right, a pen and a pencil. You need to bring a spare in case your pen is dry or is cold or something. Anything can happen, so you can never rely on one pen. We don't want you to be panicking, we want you to be calm. Make sure that you have a spare pen in case of that event. Then you need to have a ruler. I cannot emphasize the importance of a ruler. You saw where we're going to use a ruler for your table, for your diagrams, the labels on the side, and also for the lines in your graph. Then protractor. You're going to use a protractor now to determine the angles of the different sectors in a pie chart. So this is very important. You need to have for the exam. Or a compass to draw the pie chart also. You're going to also need a calculator. For you to get that 529%, you need a calculator to calculate that percentage increase or any other thing that may require calculations. Then, what are the other tips that you can follow? You can answer the same question on one page. Please. Sometimes we tell you can answer questions when you remember them, but your paper needs to be clean. We need to mark, because then you're going to lose marks. If you separate your questions in the sub questions, like you write your 2.1 this side and 2.2, and then it is followed by 3.1 and then 3.4. There is no logic there. Make sure that your sub questions are still grouped. However, if you want to write a group of question 2, then you can have question 2, 2.1 all together in one subsection. But please don't scatter them around where we cannot even find your 3.4, you cannot find your 2.1. Make sure that they are all grouped so that you don't lose marks unnecessarily. Now, if you don't know the questions, answer, or want to come back to it, you need to leave a space between. So if there were 5 marks that were asked for, you can leave 6 lines. Then you know you are giving yourself an allowance of 1 line in case your answer gets longer. So you can leave an open space like that, go write other questions, and then you can come back to it and try to fill in that space. Then please check your numbering. Numbering system, very important. Right, so it means we have come to the end of our presentation. I hope you have learned a lot when it comes to these skills. Please go and practice with all the exam papers that you have. All of the skills are tested. Please make sure that you fine-tune those skills and you get ready for the exams, and good luck for your final exams and happy practicing. Thank you.